Backface culling is one of the easiest ways to speed up an OpenGL program. And the idea is, whenever we have a closed surface, we actually don't have to draw any of the faces that are facing away from the camera. They'll always be covered up by faces that are facing towards the camera. The way that we do this in OpenGL is when we have a closed surface, for each polygon, we specify the vertices in counterclockwise order when we're facing towards the polygon. And then whenever OpenGL encounters a polygon whose vertices are in clockwise order, it knows that that polygon is facing away from the camera. And if backface culling is enabled, then it'll just cull that face. It'll skip over it. It won't draw it. And we're going to add backface culling to the spinning cube program, which I have right here. And get ready, this is going to be really hard. It's going to be crazy. GL enable, GL cull face. And that's it. Just put in that one line of code and we sped things up. We only have to draw roughly half as many polygons, so this program will run faster. It actually doesn't matter too much for a simple program like this, but for more complex programs, backface culling would be really useful. It cuts the number of polygons down roughly in half. So that's how you can enable backface culling. Actually, when I wrote the cube program, I was careful to specify all of the vertices in counterclockwise order. So I don't have to reorder any of the vertices or anything in order to get this to work. Also, you should know that if you call GL cull face GL front, then you can cull front faces. You can have OpenGL not draw any faces that are facing towards you. And it's not clear why you would want to do that. In fact, it sort of breaks this program if you put it in. But I'll show you one reason you might want to do that. And if you'll remember, if you saw the lesson on alpha blending, I mentioned that there was a nice little trick for doing alpha blending using backface culling. And let me show you how we can do that. Let me show you the little trick. We're going to go to draw scene and take all of the code for drawing a cube, and we're actually going to put it into its own function. So I'll just cut all of that. I'll go to the top here and make a new function, which will take as an argument a texture ID. And then I'll paste in that code. And we'll actually change this cube right here so that each face is transparent, so that each face has an opacity of 0.6. So to do that, we just change all of these calls to GL color 3F to calls to GL color 4F, and we put an extra parameter of 0.6 indicating the opacity. And that'll give us some transparent faces. We actually need to enable alpha blending also, so let's go to init rendering and call GL enable GL blend, and also set the blending function to be the normal transparency blending function. So GL blend func, GL source alpha, GL 1 minus source alpha. And I'm actually going to enable backface culling, and you'll see why in just a second. So now let's go down to draw scene, and what we're going to do is we're going to first of all draw all of the faces that are facing away from the screen, all of the back faces. So I just call GL cull face GL front, and I call draw cube to draw the cube. And now we're actually going to draw the cube a second time, but this time draw only the front faces, the ones that are facing towards the camera. And actually, if you think about it, this will make it so that first of all we draw the faces that are in back, and then the faces that are in front. So we can actually achieve the transparency effect without any kind of complicated sorting of faces. And this technique will work for any convex polygon. It might not work for concave polygons, but it will work for convex shapes. And if we run the program, it'll look exactly the same as the program for the lesson on alpha blending. So we accomplish transparency without any kind of complicated sorting of faces, just using backface culling. And that explains how you can use backface culling to make alpha blending or to speed up a program.